developer world looked like you mostly hack up Spring apps using Spring XML configurations. You remember maybe these times use Spring XML configuration files and things like that. So we parsed them and extract all the information and build a huge Spring model out of that and trying to understand all your namespaces and things. But that has changed, and we built that for Eclipse exclusively, right? But stuff has changed. Nowadays, people use Spring Boot, annotation-driven Java development, so we thought it might be good to rethink the way we implement the tools and the stuff that we built into the tools. So that's why we introduced Spring Tools 4. Kind of that's the latest version that we have shipped. And it's not only kind of going from Spring Tool Suite 3 to Spring Tool Suite 4, kind of a major version. It's under the hood really a complete rewrite of more or less everything inside of the tools. Which was a great decision because we were able to adopt new technologies and new architectures and kind of get rid of many of the old problems that we had with the old implementation. So what I would like to do is to take a look behind the scenes. Why did we choose to implement it the way we implemented it? Why did we made with which decisions? And how does it all work under the hood? So the overall design decisions, when we started from scratch, that was, okay, let's focus on what people should use nowadays and should use in the future. Not so much what did people choose and how did people work 10 years ago. But how should they work now? They should work using Spring Boot, and we should really kind of focus on that experience. So let's try to focus on what do people need that implement applications, real large-scale business microservice applications based on Spring Boot. And let's start from scratch. And since the IDE landscape has changed too, we decided to not focus on one specific IDE. So we thought our main power, our main knowledge is within Spring, right? We know everything about Spring. The Spring core team is on board for that. So, but we are not really experts in building Eclipse or building VS Code, and we don't want to spend our time implement general Java language support for content assist or whatever. We really would like to focus on Spring as the experience and to help people working with Spring independent of the IDE that they choose, whether you prefer Eclipse or NetBeans or Atom or VS Code or whatever. And that's also a reason why you maybe saw on the slide before that we shipped the Spring tools for different IDEs now. Beyond that, other key design decisions were developer tools. They have to be fast. So it doesn't really make sense to build huge, great, awesome new tools, but they are slow. They do not respond. They're not there. The kind of build workspace takes ages in Eclipse or whatever before they perform anything. Was kind of a sort of a problem in the old tools, and some other design decisions. So I will go into detail in the upcoming slides. So what was the focus? The focus was let's not focus on a specific IDE. Let's focus on Spring Boot. What do people need to implement Spring Boot applications? And this shift away from let's rethink the way we build developer tooling around Spring Boot and not really highly depend on a specific IDE came up to the point where the choice was obvious. The design decision, okay, we need to adopt the language server protocol for this, which is not a natural choice for the language server protocol because that is built for people implementing, as you might have from the name, it's for languages, right? You build a language, you build Rust or you build C++ or whatever, and you want language support in your IDE. That's when you implement a language server to support your language. But we found out that you can also use the same stuff, the same protocol, to support a specific framework. And I will show you how we did that. This decision made it possible for us to really focus down on what should we implement inside of the language server. Let's try to build as much stuff as possible into the language server and do not take a look outside. Do not take a look so much about learn all the different Eclipse APIs and deeply integrate into Eclipse Let's not think about how is VS Code does VS Code exactly works inside. Oh, it's built in TypeScript. Now let's re-implement everything in TypeScript and stuff like that. We were really able to go back and say, okay, our focus is Spring Boot and nothing else. So that was great. But interestingly, when you focus on Spring Boot, the question arises, what should we do for Spring Boot? I would like to help you hack a Spring Boot application. I would like to help you, but what should I do for you? Is there anything I can do to make your life easier? Because Spring Boot is mostly depends on Maven or Gradle. You put all your stuff together. You hack annotations into your source code. Annotations are nicely supported by regular Java development tools. If you use Eclipse or in another IDE, you can just use the annotations. That's all fine. But what else do you need? Typically, when you start to implement a Spring application, Spring Boot application, you start to use a lot of these Spring constructs. Right? You start to implement your data access using Spring data. You implement a specific interface. You put annotations like add service or add request mapping on your classes to connect them to the outside world, to get these kind of technology things from the outside world connected with your inside business logic that you implement. And it's really easy to get lost within all these Spring elements. So the first key for us, the first key feature was, okay, let's try to help our developers hacking on boot apps to get an overview about what is your application all about. Where are all my Spring elements and how do they fit together? So where are all my request mappings? Where are all my Spring Bean definitions? How do they work together? And the second question for that was, how does that work at runtime? Because if you are familiar with boot, and especially with Spring, you know that you can put annotations on there like auto-wired, and you get your dependencies automatically wired into your beans. That's great, but what happens at runtime? What gets really injected into that bean could be different, right? You deploy your app and suddenly a different data source gets injected because you don't want to use the in-memory data source. You want to use the Postgres data source coming from your application server environment or whatever. So, and sometimes things are weird. You don't really know what's going on. So we would like to give you information about what's going on behind the scenes, which is another really interesting challenge. But those are the two key elements beyond providing you content assist where it's necessary, code snippets, and all the, let's say, the regular features. And the Spring specific overview is that's really cool because it gives you really this super quick and super easy to use navigation of all your Spring elements. And that's based and implemented using the language server protocol. So we thought about, okay, we want to give people a quick overview and a quick navigation. And on the other side, we have the language server protocol. How does these two things fit together? How can we use the language server protocol in order to fulfill this feature request? And the language server protocol provides this nice infrastructure for symbols. It's usually designed to extract the symbols like class names and field names and things like that out of your source code and give you an overview about the outline, for example, list of symbols, or all the class names in your project, kind of the symbols in your workspace. But we thought maybe it's good to do the same for Spring. So extract Spring specific symbols out of the source code and give you and provide you as an overview using this infrastructure. So this allows you super easy navigation and super easy overviews. And in order to show you how we did that, I would like to show you the feature, how that works, and how does that behave. For that, I switched to VS Code. In VS Code here, in my VS Code environment, I have a pretty significant Spring Boot application, which is the Sagan application. It is basically the application that runs spring.io. So whenever you go to spring.io, to the website, everything that's inside of spring.io, including the blogs and the admin stuff behind the scenes and everything, that's powered by the Sagan application. It's a Spring Boot application running on the cloud. and have the source code imported. Fairly huge stuff. So this is demo stuff, some additional things, but here you can see quite a bunch of stuff going on here. And if I would like to get an overview about, for example, hey, what are all my request mappings? I can do the search for symbols in workspace, and whenever I press add, I see all the symbols that are provided by the Spring Boot language server. And when I do add slash, I see all the request mappings. In this case, some of my demo app, but let's say, let me give an overview about what's in the block section. It's filtered down to the symbols that are add request mapping / block for the block path. So I can easily see all the request mappings inside of my Spring application that I defined in my annotations. And this is something that the language server under the hood extracts. So it analyzes your source code, looks at the annotations, at the get mapping, post mapping, and so on, extracts out the path and the additional information, and turns that into symbols for the language server. And the language server returns the list of symbols. And to easily navigate that, there's always a common prefix, which is the add for the annotation. The same happens if I do add plus. If I do add plus, there's not request mappings anymore, but bean definitions. So for example, if I would like to see, oh, there must be bean definition that's called maybe data source, I can just see, oh, there's a bean definition where the bean ID is data source. Let's jump to that. Oh, I'm here. Oh, on the profile on Cloud Foundry, I see there's a bean called data source that's being defined this way. I can easily navigate and search for all those things. So the language server is really smart enough to understand your source code and to see what's Spring related in your source code and extracts you all these symbols out and provides you with a language server to the client. Really easy to get an overview, really easy to navigate, find specific elements, especially the Spring specific elements, because the more you implement Spring apps, the more you think in the terms of your Spring stereotypes and Spring elements inside. Okay, so let me switch back to the slides. Internally, we parse Java code. So the language server runs side by side with your editor, and it parses Java code, generates the AST behind the scenes, and just the AST resolves the type bindings, and walks through that AST and analyzes all the annotations and the elements and tries to find the Spring spots in your source code. We do that by reusing the JDT Java parser. But this is not JDT running as it is running in Eclipse, but in the language server. It's really stripped down to just use the parsing of source code and reusing JDT as a Maven dependency to parse source code. It's kind of configuring a little bit the parser, setting that up. That's quite a common use case for reusing JDT as for parsing Java code, and you put the stuff in, you get the ASTs back, resolve the types, and then you can take a look at what's inside. Okay, so the next part that I talked about is runtime information. So we would like to tell you what's going on inside of your Spring application, and that information should also be delivered and extracted by the language server, because we try to build everything into the language server. So what the language server does, it tries to find the information from the running application and turns that into, and again the question came up, how can we put that into the language server protocol? What makes sense? It turns that into code lances and hover information. So whenever you hover over a specific Spring element in your source code, a hover appears and shows you information about your running application, some kind of overlay, kind of a second dimension to your source code provided by the language server in the way of a hover, because the language server can provide hovers. That's what language designers usually do to, when you hover in JDT over a certain element, you see the definition or the Java doc or something like that. And for us, for Spring elements, we show you live information from the app, in addition to code lenses. I would like to show you how that looks like in reality. Again, so switching over to in this case to the Spring Tools 4 for Eclipse, so not the VS Code version, but the Eclipse version. So I have, of course, the most famous Spring demo application, Pet Clinic. I think that's there for even longer than Spring exists. And what happens in your source code is that kind of highlights appear whenever there's information from the running app showing up. So when I hover over this, I see, oh, there's a bean created at runtime in this process. See a little bit of process information from this running process. The interesting thing is that the language server analyzes what's going on at the running application and visualizes that using the language server protocol. In this case, for example, when you go to the owner controller, that's a controller. You see the owner controller is there's something being auto-wired. The repository is auto-wired into the controller. But are you sure which one's really being auto-wired at runtime? So you can hover over and you can see directly, okay, there's a bean called owner repository auto-wired here. So this actually really happens at runtime. It's nothing that we guess from looking at the source code, nothing that we think could happen. It's something that actually happens at runtime in your running application, and we put that additional dimension on top of your source code. And you can jump to that if you want to. So there's direct navigation. And in addition to that, there's kind of a summary showing up as a code lens here. So you can see with these left arrows, something is being auto-wired into this component. And when I would like to see, oh, where does it component really come from? So sometimes, oh, there's a owner repository, but where the hell is that being defined? Who defined this crazy repository thing? I can just jump over to that and I see, okay, this is my owner repository in my project. And I see the same for this bean. There's a bean being created at runtime for this component. And I see both ways, right? So when I hover over, I see this one is being injected into, that's the arrow to the right, injected into the owner controller, and in this case in the pet controller. And something else is being auto-wired into this one, which is the JPA meta model mapping context, something you can even see in the source code because it's kind of a JPA created repository for you. And I could go back to say, okay, the owner controller is, go back here and I see, okay, I can navigate. So this second dimension is being put on top of the source code, something that's kind of completely new, something you were never really able to see for a Spring application and get visualized. What happens at runtime actually directly in your source code. And that's how we use the language server protocol to inject that directly into your editor. Oh, by the way, I forgot, if you want to ask questions, I'm also happy to answer questions in between, because I see there's a question mark appearing. So thought I should mention that. Yeah, a question. Yeah, the question is, how does the language server, the Spring Boot language, connects to the running application? And I will answer that when I go back to the slides on the next slide. Thanks for the question. A completely different layer, right? And we use the language server protocol to connect this language server to the client with that specific information. We don't really have to do anything special for Eclipse for VS Code. The same stuff shows up in the same way in VS Code. Right? There's a highlight showing up. If you hover over, the same hover appears, which is very nice for us. Okay, so let me go back to the slides as promised. And internally, the language server does something a little bit crazy, but it is really trying to be smart about that, because it looks up every Java process on your machine automatically for you. You don't have to configure anything. It doesn't really matter who started the process. So even if I use Eclipse to implement my stuff and I go back to VS Code, the hover show up in VS Code, even the process was started by Eclipse, doesn't matter. It inspects every Java process on your machine and tries to find out which one is a Spring Boot process And whenever it finds a Spring Boot process, it tries to extract the data by calling JMX to the process and trying to find the Spring Boot actuators. It's a specific Spring Boot module that you can put on your project to inspect the project at runtime. The actuators provide you kind of health information, metrics, things like that. So they are originally designed for inspecting apps at runtime in some kind of deployed way, where you can see, okay, how does my Spring Boot application behave in the cloud or things like that. But you can use these actuators, endpoints, to grab the data out and visualize them nicely in an IDE, and that's what the language server does. So it looks at your machine, tries to find the Java processes, which one is a boot process, tries to find the actuators, and then, of course, it tries, and it's really smart about, matching that back to your source code. That's where our Spring Boot magic knowledge, it's not really magic, right? But how the Spring Boot knowledge comes back into the game, saying, okay, how do you match this actuator information back onto the source code, and how to make some kind of meaningful sense out of that. And that's what we implemented. The cool thing about that is that the language server can do whatever it wants, right? It's independent from the clients, who can also do that for multiple apps running. So if you have 5 different instances of the pet clinic application running on your machine, it can display the information for all 5 pet clinic instances. So for example, you run that in configuration A, configuration B, configuration C, and you would like to see the difference, you can just run all 3, hover over the elements, and you see the information for every single instance of the application that's running. And another nice fact about that, because it's so nicely decoupled into the language server, and the language server itself kind of just calls out to the actuators on the boot apps. You can do that for remote apps too. So if you deploy your app, for example, using the tools to Cloud Foundry instance, or to wherever, there's no specific requirement for that. As long as you can create a tunnel and JMX access to that app, to that instance, which you can do in most of the cloud environments, right? You can somehow get SSH access to the pod on Kubernetes or onto the container in Cloud Foundry, and tunnel the JMX traffic through that. You can configure that in the tooling so that you can see the same information for a remote app on your cloud. For example, whenever you ask yourself, why the hell is something going on wrong on my deployed app? It's running so nicely on my local machine. What the hell is the difference? I just press deploy. You could connect. You could run it on your local machine. You can connect it to both, and you can hover over the elements and see the difference, right? You can see exactly what, okay, this data source is being wired at runtime in the cloud. This data source is being wired on my local app, which I think is really an awesome step forward for hacking on Spring apps. Those are the 2 really main, most awesome features. Of course, there was another question for us, because the old tooling had something like validations. Like, okay, there's an XML file, and let's wire bean A into bean B and put this into a property called Z, whatever. Let's do some validations if people put the right stuff into the XML file, basically, because you cannot be sure, right? Nobody is really analyzing that until you start up the application. We thought about, should we do something like that again, like trying to be smart in the tooling, guess stuff, and do some validations. And we decided against validations. So we don't do any validations anymore. Basically because Spring Boot applications are being more and more dynamic over time. They're getting more and more dynamic. So they're creating beans at runtime. So it's really hard to guess, by just looking and analyzing the source code, to guess exactly what happens at runtime. You more or less would have to rebuild the whole Spring framework and execute everything within the IDE to be really sure, and then you would even have to execute the code of the application itself, because there could be some kind of magic being creation in the application code itself. It could be implemented somehow in source code. You don't even know that. What happens is really hard, and people from the Spring team told us that they are getting more and more false warnings in their IDEs because of validations going crazy, and they think something's not there, even it is there. because it gets really hard. So we decided, let's not do that anymore. Instead, provide this clear distinction between showing symbols, so giving you a super quick overview about everything that's inside, and that's only based on source code analysis. Purely source code. Looking at your code, at your libraries, giving you an overview about what's in your source code. If you have 5 different data sources in your source code, and for 5 different profiles, all 5 definitions will show up. It will not select one. Everything shows up in your source code. And on the other side, provide the information what's going on in your live application. So what's really going on whenever you press run in your Spring Boot app. And performance is key for that. So if you have seen pressing these, give me all the symbols, even for a huge Spring app, it's really fast. Parsing the source code, it's really fast. It's more or less instantaneously. It's really good. And since we implement everything in the language server, also a nice side effect of that is it's not blocking the UI. So whatever the language server is doing behind the scenes, and even if it's doing more complicated stuff, you can continue write your code in your editor. There's no blocking going on. There's no waiting for the language server to process something. It all happens in the background by design, fully automatically. But we, of course, have to optimize performance inside of the language server because we would like to make it as lightweight as possible and as fast as possible, of course. An interesting question, although, comes up when I talk about the language server analyzes your source code. It has to understand, oh, this is Java, has to parse Java code. And if you read through the code, took a look at everything in the code, how to parse Java files, Java code, and I told you we resolve types, we need to resolve the class path of the project because otherwise we don't know how to resolve all the types. So how do we get the class path? Because the language server usually understands files. It gets files or a file structure on disk, and that's it. And you're done, right? It has no idea about class path containers or whatever. There's no nice API. Oh, please give me all the dependencies. So our first attempt for that was, oh yeah, let's do it ourselves. Let's call Maven if we find a POM file, or let's call the Gradle tooling wrapper if we find a Gradle file, which of course resulted in the language service doing the work twice. Right? The IDE resolves all the Maven dependencies and grabs everything from the internet and creates computes a huge model for Maven, whatever. And then the language server kicks in and says, oh, I would like to parse Java code. Let's do the same stuff again. Let's call Maven to resolve everything. That's expensive. And it's slow. It takes a long time for the language server to actually come up with a meaningful result when you try to find, for example, your symbols, because it has to resolve all the stuff through Maven or through Gradle, which can be pretty slow. So we changed that. From the beginning, some kind of in the middle of the process, after going with the first attempt for maybe, I don't know, several months, we switched that over and we communicate with the outside world with the Java language tooling. So whatever Java language tooling you have around, in VS Code, you have the Java language server installed from Red Hat, or in Eclipse, you have the JDT around, or in Atom, you have also the Java language server around. We send commands forth and back to the outside world to say, hey, Java tooling outside there, please give us the resolved class path of the project and tell us what the project is. Because if you just get a file structure, you don't even know where to find exactly the projects. Is that this multi-module thing or just a single module thing or whatever? Is it nested or not? And sometimes you come up with a different decision than the Java tooling, and then everybody's confused because we think this is a project and the Java tooling thinks the other thing is a project. So it's easier and better to just call out to the world and say, hey, give me the stuff, which is pretty tricky to do, but can be done. So it's just calling out to the outside world to understand that. And then it gets the class path back, which is hard to debug. So that's kind of a side effect, but it's pretty fast. Communication costs more or less nothing. And you get exactly the right information in this, especially the same information than the Java tooling. So nobody gets confused about that. And it saves you a lot of resources because you don't have, Maven doesn't have to do the same work twice, which I think is great. So let's have some outlook. So when I go a step back, so we ship the first release. So what comes next? I think these additional layer that we put on top of the source code with the live information for the bean wirings. I did not show you, but there's also request mapping showing up there, so you can directly click on the code lens to jump to the request mapping thing, for example. It's just the beginning. I think we can leverage this idea and basic architecture even more to provide more and more information from the running applications, either from the cloud or from running stuff locally, and merge them on top of your source code to see directly stuff in your source code, because that's the stuff that makes sense, right? It doesn't really make sense to say, oh, something goes wrong in my live running app, let's take a look over there, and then try to translate in my head back stuff into the source code. Where do I find the right piece? It really makes sense to let the IDE do that for you, right? Directly insert the information in your source code where it actually happens. I think there's a lot of potential inside. And another interesting new track on our end is to implement the language server as a Spring Boot application. So we can now start to do that. So we can use our own tooling and eat our own dog food to build the language server up with Spring Boot, because it's just a regular process, right? So you don't have any dependencies to the outside world, like, oh, it has to run in Eclipse or whatever. It's just a regular process. One of the challenges is still to keep it small and to keep it fast. Because as you can imagine, for something like this, you start to explore new ideas. So you bring in new stuff, you provide more features, add more dependencies, so the language server gets bigger and bigger and bigger. More dependencies, more libraries. Everything is included in this big jar file that you ship as a language server, dump on the machine. And I'm really a big fan of keeping it small, lightweight, and fast. But that's a kind of a constant challenge. But on the positive side, I think it would also allow us, and that's what we are going to do, is to ship updates to the language server independent of everything else. So in the past, we shipped a new Eclipse version, Eclipse distribution with the Spring tooling included, more or less at the same time with a big new Eclipse release came out, and things like that. And now we are more or less independent of that. We can just ship updates to the language server, deploy that, and people can just update the language server in their distribution in VS Code and Eclipse, and that's it. And they get new features, which I think is really great. So it's a wonderful future ahead of us. And that's it, my quick summary of behind the scenes stuff. If you want to know more, feel free to ask questions or come up to the stage. I'm here all week. Happy to answer questions and discuss stuff with you. If you want to know more about how the way we integrate with Java tooling in Eclipse, there's another talk on Thursday where I dive a little bit deeper into the code, to the extensions. And yeah, that's it. Hope you enjoyed it. Thanks for coming.